Hey everybody. Chapter 11 is about break-even analysis and sensitivity analysis. And we've already talked this semester about break-even points. We've done a lot of examples of break-even analysis. So my hope is that this week in Chapter 11, it's going to be a fairly easy set of material for you. And half of homework 5 is related to that. So hopefully you'll find these types of problems very familiar, and it's really just about getting a little more practice. So we had an example earlier in the semester about iPhones in one of the first weeks of class and asked how many iPhones does Apple need to sell in order to first become profitable. We were talking then about the relationship between price and demand. And so we had this figure here where we can identify there are two break-even points where revenue becomes greater than cost. And then as they sell more and more, eventually revenue dips below cost again because in order to sell that many, they have to lower the price. And so more generally, we were thinking about what's the price range that Apple could set that would result in making a profit. And so we found those ranges as our break-even points. So that was a simple example where we had things like annual sales or quantities of production, and then the unit costs or prices associated with break-even points. But now we've got lots of other quantities and more complicated examples that we could work through that we've been doing throughout the semester. What's different about it this time is just the way that we're framing it and thinking about break-even analysis as uncertainty analysis of a kind. So if we have estimated some of the parameter values in our problem, but we don't know what they are for sure, then we can develop our economic model and then look at what the break-even analysis is for the threshold for that parameter, at which point we would change our decision. So remember, that's always our goal, is not necessarily to identify exactly what the break-even point is. That's nice, but we want to use that to make a good decision. And that's really our goal. And so even if we're uncertain about exactly what a parameter value is, then if we identify the break-even point for that parameter, that may allow us to be more confident that we're making the right decision if we know that we're on one side or the other of that break-even threshold, even if we don't know the exact value of the parameter itself. In this video and the videos to come, we're going to use the same example in order to talk about break-even analysis, look at it as being a little bit more complicated, where potentially multiple parameters are uncertain, and we want to express the break-even value of one parameter as a function of others. And then we'll do a little bit of work showing you how data tables work in Excel, which would be another way to explore this same concept. And then finally, we'll talk about sensitivity analysis using this same example. So go ahead, take a moment, pause the video, read the problem, and see if you can work it yourself. And we're back. This problem is a little interesting. We need to think about what it means to recover our investment within 4 years. Because we already have this 2005 Honda Civic, the problem is really a thinly disguised replacement analysis. What we're really asking about is how many miles do we need to drive per year in order to justify replacing the Civic with the Yaris? It's not really just about this initial investment of $4,500 in the Yaris, because these are both cost alternatives. We have an opportunity cost associated with keeping the Civic of the $2,800 that we could sell it for today. And in either case, we're still going to be driving, we're still going to be getting a certain amount of mileage, and so then we have that plus the O&M costs that are going to be annual costs going into the future. So when you see how many miles per year do we need to drive to recover our investment within 4 years, all that really is saying is that our planning horizon is 4 years, and we want to know how many miles per year would cause us to choose the Yaris to replace the Civic now. Now let's talk about how to actually calculate the present worth of each of these cost alternatives. The structure is going to be identical. So if we want to put this in present value terms, we have an initial investment, which for the Honda Civic is the opportunity cost that we're giving up by not selling it today. And for the Yaris, it's the actual purchase price. And then we have our annual expenses, and that is a combination of fuel costs and O&M costs, where we're given an amount for the operations and maintenance, and then we have to calculate our fuel costs. And in this case, since our question is asking about how many miles we need to drive per year, then we want to express this on an annual basis, miles per year, and we need to think about keeping that as our unknown variable. So our fuel costs are going to be however many miles we drive divided by the miles per gallon times the price of gas per gallon. Simple unit conversion. Then we take that, add the O&M costs, and multiply the sum by a P given A factor in order to convert it to a present worth terms. And then we subtract off the salvage value that we would have at the end of the planning horizon for each car, which is expressed at the end of year 4. And so we need to multiply that by a P given F to bring it back to present worth term as well. Given this structure, we can substitute in the values for each of the cars, the Civic and the Yaris, and then all we need to do is set them equal to each other and solve for y. That'll give us the break-even point of the number of miles per year that we would need to drive to be indifferent between keeping the Civic or replacing it with the Yaris. Take a moment and make sure that if you equate these two expressions and solve for y, you also would get 7,784 miles per year. That's a version of this problem that I could have assigned earlier in the semester, and I don't think many of you would have had trouble with it. In the next video, we'll talk about what to do if multiple parameters in our economic model are uncertain, and how to address that both algebraically and in Excel. Then we'll also talk about some features in Excel that can allow you to do this same kind of analysis even in situations where the algebra can't be solved explicitly.